Alright, so in problem 17, we now have a group of 12 people. And we're talking about left-handed and right-handed people. So 13% of people are left-handed, 87% of people are right-handed. So find the mean and standard deviation of the number of right-handed in this group of 12. Okay, so let's go and do that. So the mean and standard deviation, the mean is going to be NP, which is going to be 12 times 0.87, and that's going to come out to 10.44 righties. Standard deviation is the square root of NPQ, which is the square root of 12 times 0.87 times 0.13, and the standard deviation is 1.16. Okay. Question B says, what's the probability that they're not all right-handed? Probability not all right-handed. Well, what's that the same thing as saying that they're not all right-handed? It's the same thing as saying probability of at least one lefty. Okay, it's basically what they're trying to say in a different way. So how do we do at least one? We do 1 minus the probability of no lefties. Okay, so in that one, we would do one minus 0.87 to the 12. And if we do that, we wind up with 0.812. Okay? This should be lefty, not leftly. Okay, C. What's the probability there are no more than 10 righties? No more than 10. So I can have 0, I can have 1, I can have 2, all the way up to 10. Okay? Okay, so you can do each of these separately doing norm PDF, which would be long. But what sums from 0 to 10 for us is binom CDF. Okay, now we would probably want to show a little bit of nomenclature here. So the probability of no lefties, so that would be 12 choose 0, 0.87 to the 0, 0.13 to the 12th, plus one lefty, or one righty, would be 12 choose 1, 0.87 to the first times 0.13 to the 11th, and then I would just go up to the 10th one. Alright, so we're going to do 12 choose 10, and that means we got 10 righties and 2 lefties. Got it? And then I'm going to just do this in the calculator. Okay, so I'm going to go to the calculator, I'm going to go to binom CDF, not PDF, and we're going to say okay. Let me clear that. Binom CDF, we got 12, we got 0.87, and we got 10. So the probability of that is about 0.475. Okay. B. What's the probability there are exactly 6 of each? Okay, well that's a pretty straightforward question. So the probability, we could do 6, I'm going to do 6 righties. Okay, what's the probability of 6 righties? And that would be 12 choose 6, and that's 0.87 to the 6th, 0.13 to the 6th, and this is a binom PDF problem, because we're just looking for one probability. We're not looking for any kind of sum here. So binom PDF, 12, comma, 0.87, comma, 6. Okay? And you get 0.0012. Well, Mr. O'Neill, I wanted to do it the other way. I wanted to do 12 probability of 6 lefties. So if that changes to 0.13, comes out the same answer. So you could have done it either way. It doesn't make a difference. So the answer is 0.002. And then in question E, what's the probability that the majority is right-handed? Okay, so majority, we got 12 people, so that means 7 or more, or at least 7. So the probability of at least 7 righties. And that's the probability of 7, 8, 9, 10, 11, and 12. Okay? Well, what I'm going to wind up doing to do this problem, you could do 7, 8, 9, 10, 11, and 12 separately and add them. I'm going to wind up doing 1 minus the probability of 0 all the way up to the probability of 6. And how do I do that? I do binom CDF, cumulative CDF, not PDF. I want it to sum, and I'm going to do 12 comma 0.87 comma 6, and I'm going to let it do that. So I'm going to do 1 minus binom CDF 12 comma 0.87 comma 6, and you get 0.9977, about 0.998, and that's our answer.